Hello students, today we are going to solve a trigonometric word problem. Okay, so here the question is an aeroplane at an altitude of 1200 meters finds that two ships are sailing towards it in the same direction. The angles of depression of the ships as observed from the aeroplane are 60 degrees and 30 degrees respectively. Find the distance between the two ships. So the important thing what we need to do is we need to find the distance between the two ships. First, let me draw the figure of the given information. The aeroplane is here and the water bed is here. Okay. Let us take the height of the ship, the aeroplane as AB, which is 1200 meters given. From the aeroplane, they are seeing two ships. Let me mark it as C and D as the two ships. From the aeroplane, we are seeing the two ships means it is angle of depression. We need to frame an imaginary line along the aeroplane path. So we have drawn the imaginary line which should be parallel to this one, to the sea level and the in the air. Now from here he is seeing one ship at D and the other ship at C. Now they gave that the angle of depression one is 30 degrees and the other one is 60 degrees. Now we need to find the distance between the CD. To find the distance between CD, we will be using trigonometric ratios. For that, we need the angle C and angle D. How to find angle C and angle D? Angle C is got. Now we will use parallel lines in which alternate interior angles are equal. So let us draw a Z shape like this. This forms an alternate interior angle. This angle 30 will come here 30 degrees and the other one I'll make it with a green color. Now this is angle of depression 60 degrees. So the line this will go from here to here. This is 60 degrees. Now we are done with the angles of depression to the angles of elevation. Now I am going to take the triangles ACB and ADB triangles to find the distance between CD. How to find the distance between CD is we do from BC minus BD is equal to CD. This is the thing we need now. Let us take the triangle ACB. In this triangle ACB, we are going to use the trigonometric ratios for this triangle. Now AB is the height and CB is the base, that is the adjacent side. So whenever we have the height and adjacent side, we use a trigonometric ratio tan. So tan 30 degrees is equal to opposite side by adjacent side. Adjacent side, where at tan 30 is 1 by root 3 value and opposite side is 1200 and the adjacent side is BC. From here, we will find out BC. BC is equal to, I do cross multiply, 1200 into root 3. This is our equation 1. Now we need to find BD. BD means I am going to take a triangle ABD. From this triangle, again we are going to use tan only because AB is the altitude and BD is the adjacent side. So whenever altitude and adjacent side are there, we use tan. So tan 60 degrees is equal to same formula, opposite side by adjacent side, that is AB by BD. AB is equal to 1200 and we don't know BD, keep it as it is. Tan 60 value is root 3. Root 3 is equal to 1200 by BD. Now, BD is equal to 1200 by root 3. This is our equation 2. We already told that BC minus BD is equal to CD. We are going to substitute this in these equations. Substitute 1 and 2 equations in BC minus BD is equal to CD. So BC is what? 1200 root 3 minus 1200 by root 3 is equal to CD. Now, we need to take an LCM root 3. Root 3 into root 3 is 3. So, 1200 into root 3, 1200 into 3. It becomes root 3 into root 3 is 3 minus 1200. Now 1200 into 3 and this is nothing but 1200 into 1. No need to multiply. 3 minus 1 is 2. So we can write it as 1200 into 2 by root 3. Whenever we have a denominator root 3, we use rationalization also by root 3. So root 3 into root 3 is 3. 1200 into 2 into root 3 by 3. 3 ones are 3 fours are so 400. That is nothing but 800 root 3. Root 3 value is 1.732. So 800 into 1.732. That is nothing but when we multiply, we get 1385.6 meters. This is the distance between the two ships. In this chapter, we are using parallel lines, alternate interior angles we are using, trigonometric ratios we are using, and rationalization also. 3 things are combined from 3 chapters from we get the question. Thank you.